I want you to picture something for me.
Okay.
The year is 1954, and you're trying to visit a highly classified museum.
Good luck with that.
Right. First off, you're in Los Alamos, New Mexico. So just getting past the town's security perimeter is a massive hurdle all on its own.
Yeah, it was basically a fortress town back then.
Exactly. But let's say you actually managed that because, you're an official government visitor with the highest possible security clearances.
Mm-hmm.
You walk up to this museum and you're probably expecting, I don't know, some sleek concrete government bunker, but it's not. It looks like a repurposed kind of rustic old ice house sitting right next to a duck pond.
A literal ice house.
A literal ice house. But blocking your way into this ice house is a heavy, impenetrable steel vault door.
Which is such a bizarre visual.
It really is. So you get cleared, that massive vault door swings open, and you step inside what is essentially a shed to view top-secret relics from the dawn of the atomic age.
It's such a surreal image, isn't it? You have the most terrifying cutting-edge science on the entire planet, stuffed into a rustic shack meant for keeping blocks of ice cold.
Yeah.
But looking through the stack of historical notes and source materials we have for today, that absurdity is completely real.
And that is our mission for today's deep dive. We are tracing the bizarre and just really fascinating evolution of the Bradbury Science Museum.
Yeah.
We're going to explore how a literal vault of atomic secrets, completely locked away from the public eye, transformed over the decades into a free, open hub of scientific discovery.
What's fascinating here is the evolution of transparency.
Oh, absolutely.
As you dig into these sources, you see this massive contrast between two very distinct eras. On one side, there's the intense, almost paranoid secrecy of the early Manhattan Project and the post-World War II weapons programs.
Right.
And then on the flip side, you have the museum's modern, totally open-door policy. It's really a physical timeline showing how society's relationship with classified science has completely shifted.
Okay, let's unpack this and go back to that origin story.
Let's do it.
So we're in 1953. There's a guy named Robert Krohn. He was overseeing early nuclear testing at what was then called the Los Alamos Scientific Laboratory.
Right, the lab.
Right. And right in the middle of all this world-altering weapons research, he has this realization. They are generating physical relics of this history right then and there. And he decides they need a dedicated place to preserve them.
Which, is an incredibly rare mindset to have in 1953.
Yeah, you'd think they'd just be focused on the next big test.
Exactly. When you're in the thick of a massive ongoing military effort, you're usually focused entirely on the next breakthrough. Preservation is an afterthought, if it's a thought at all.
Right.
But Krohn recognized that the physical artifacts of the atomic age needed to be saved before they were just dismantled or tossed in a landfill somewhere.
So he pitches this preservation idea to Norris E. Bradbury.
The director.
Yeah, Bradbury was the laboratory's second director. He took over right after the war in 1945 and ended up serving until 1970.
That's a long tenure.
Very long. So Bradbury hears Krohn out and says, sure, this is a great idea to preserve the history, but he's very specific about who gets to see it. It's going to be a great place for official visitors.
Right, there's a huge caveat there. This wasn't a tourist attraction for you and your family.
Yeah.
If you didn't have the right badge, you didn't even know it existed.
And that brings us to the location they picked. I would have assumed they'd construct some highly secure, climate-controlled facility for these historical artifacts.
You would think so.
But no, they found an old ice house on the bank of Ashley Pond right across from Fuller Lodge. Like, why an ice house?
Well, early Los Alamos was notorious for its sort of duct tape and wire approach to infrastructure.
Oh, really?
Yeah, they were constantly repurposing existing town structures because the lab had grown so fast during the war, they just used whatever was available.
Yeah.
But the ice house wasn't just chosen for convenience. It had one very specific, crucial feature.
The vault door. The source material specifically points out that the ice house already had a heavy vault door fitted onto it. Because of that one feature, this rustic little building somehow satisfied the strict security standards required for housing highly classified exhibits.
It's crazy.
It really is. So they loaded up, and in 1954, the Ice House Museum officially opens to cleared personnel.
It is the perfect metaphor for the psychology of that era.
How so?
Just think about it. Having your most important knowledge literally locked in a shed behind a heavy steel door perfectly captures the post-World War II environment. The Cold War was ramping up, and the science they were preserving was considered the ultimate national security asset.
Yeah, that makes sense.
Of course, the museum had to be a fortress. The knowledge itself was
But
weaponized.
secrets have a shelf life, right? Let's jump ahead to the 1960s. We hit 1963, and there's a major vibe shift.
A huge one.
We meet Robert Porton, who is the director of community relations at the laboratory. And Porton pushes for something that probably sounded completely radical at the time.
Unclassified exhibits.
Yes. He wants to add unclassified exhibits so the general public can finally walk in and see what's actually happening up there.
Porton's role is really key here. As the community relations director, his entire job is managing the interface between this hyper-secretive lab and the outside world.
Right.
He clearly realized that you can't keep a facility that's impacting global geopolitics completely opaque forever. The town of Los Alamos was slowly becoming less of a closed military base, and the lab needed to adjust to that new reality.
So Porton takes this pitch to Bradbury, who's still running the show, and surprisingly, Bradbury greenlights it.
He does.
He approves an area for unclassified exhibits that anyone can just walk into. So for the first time ever, average citizens can view World War II era documents. They're looking at photographs, tracking the development of the town and the lab. They've got scientific memorabilia out, and even working models of unclassified research projects.
Imagine being a local, or really anyone in America at that time.
I can't even imagine.
For almost 2 decades, Los Alamos had been this mythical, restricted city on a hill. Everyone knew world-changing physics was happening up there, but it was a total black box.
Yeah.
The moment that curtain is pulled back, even just an inch, people are going to flock to it.
And flock they did.
Yeah.
The numbers here are just wild. In its very first year of being open to the public, the museum saw 14,000 visitors.
Wow.
And these weren't just folks driving up from Santa Fe for the afternoon. These 14,000 people came from 50 different states and 40 different countries.
In 1963.
In 1963. Traveling to a remote mountain town in New Mexico wasn't exactly a smooth interstate highway trip back then.
That statistic is so telling. It highlights this universal human trait. When you tell people a secret is happening behind closed doors, they become desperate to understand it.
Absolutely.
Those 14,000 visitors prove that the public didn't just want to read headlines about atomic energy. They wanted a tangible connection to the science that was actively shaping their world. They had a deep, deep hunger to comprehend it.
And that hunger meant they outgrew the space almost instantly. By 1965, which is just 2 years after the public opening, they had to move the museum to larger quarters.
They have no choice.
And what I really love about this era is how organic the exhibits were. The number of displays was skyrocketing because the active scientists within the laboratory were personally building and contributing hands-on models of their unclassified work.
That's a huge operational shift right there. It stops being just a dusty repository for historical oddities and becomes this dynamic educational space. The scientists themselves were really buying into the idea of public engagement. They actually wanted to explain their work.
Which perfectly sets the stage for the massive professionalization of the museum from the 1970s through the 1990s. In 1970, the facility gets formally named the Norris E. Bradbury Science Museum.
Honoring the director.
Exactly, honoring the director who oversaw both the classified opening and the public expansion. And of course, we know it today simply as the Bradbury Science Museum.
It's a well-deserved nod. But the real transformation happens a bit later.
Yeah, it does. In 1981, they undergo major renovations. They shift away from those informal scientist-donated models to a highly professional museum atmosphere. They bring in what was absolutely cutting-edge technology for the early 80s.
Oh, yeah.
Videotapes, interactive computer programs, and video discs.
Video discs. Nothing screams 1981 quite like a video disc.
Right.
But jokes aside, that technology actually shows a real investment in pedagogy. They're trying to actively teach complex concepts, not just put cool-looking metal casings behind glass.
Speaking of metal casings, though, the artifacts got a major upgrade during this time, too. The source material lists some specific additions from this era. They brought in a Mark 12A warhead.
Okay.
They added models of the Vela and Navistar satellites. They even put an air-launched cruise missile right on display.
Let's pause on those artifacts for a second, because they aren't just random military hardware. They tell the story of the Cold War's progression. Take the Vela satellites, for instance.
Yeah, the notes mention they were used for verification. What exactly does that mean in this context?
Verification is essentially a polite Cold War term for making sure the other side isn't secretly detonating nukes.
Ah, okay.
Yeah, after the partial nuclear test ban treaty in the 60s, you couldn't test weapons in the atmosphere or in space anymore. So Los Alamos helped develop the Vela satellite network to look for the specific bursts of gamma rays and X-rays that a nuclear explosion gives off.
Oh, wow.
So when you're looking at a Vela model in the museum, you're looking at the actual birth of modern space-based nuclear surveillance.
That adds so much weight to what you're actually looking at. And Navistar.
Navistar was essentially the precursor technology to the GPS network we all use on our phones today.
No way.
Yeah. And the cruise missile represents the shift toward precision delivery systems. As these technologies matured and eventually became declassified, they moved straight from the active defense grid right into the museum.
Here's where it gets really interesting. Because of all these incredible artifacts and the updated tech, by 1987, the public's appetite for the museum completely exploded.
I can imagine.
Annual attendance hit 80,000 people.
80,000.
80,000. It got so chaotic that visitor parking was just non-existent. The town's infrastructure couldn't handle the volume of people trying to learn about the lab's work.
80,000 people flooding into Los Alamos is a logistical nightmare for a small town. But it's also a clear indicator that the museum was no longer just a side project. It had become a primary cultural and educational institution.
So the lab officials realized they have to relocate entirely. In April 1993, the museum makes a massive move to its present location at 1350 Central Avenue.
Right in town.
Right in the heart of downtown Los Alamos. The building is specifically designed for them by William Agnew and Associates, and interestingly, it's actually leased by the laboratory from a private owner.
Taking the museum out of the direct footprint of the lab and dropping it squarely into the civilian downtown area is a really powerful symbolic gesture. It literally centers science in the public community.
Which brings us to the museum as it stands today. If you, listening to this, were to walk through the doors of the Bradbury Science Museum right now, you'd find a facility run by director Linda Tedek. And the kicker, admission is completely free. You can just walk right in off the street.
Removing the financial barrier entirely is the ultimate commitment to that transparency Portland was pushing for back in the 60s.
They're open almost every single day of the year, only closing for Thanksgiving, Christmas, and New Year's. And when you walk inside, you're greeted by roughly 40 interactive exhibits. We are a long, long way from the ice house.
It's a massive leap, and the scope of what those 40 exhibits cover is staggering.
It really is. You've got the historical heavyweights, of course. The museum traces the history of the World War II Manhattan Project in deep detail.
Right.
Among these historical artifacts, they display full-size models of the Little Boy and Fat Man atomic bombs. They also have the original leaflets that were dropped on Hiroshima, which warned the Japanese of further atomic attacks unless their government surrendered. Now, the museum presents these strictly as factual historical artifacts of the era. They are preserved purely for the public to observe the physical reality of what was built there.
And presuming that physical reality is the core function of a historical archive. Providing unfiltered access to these artifacts allows visitors to confront the sheer scale and reality of the Manhattan Project firsthand without any abstraction.
But the museum isn't just a time capsule. It is heavily focused on the present and the future. Alongside the WWIR history, they highlight the lab's current research. For example, they have an entire exhibit on nuclear weapons stockpile stewardship.
Which I know sounds like dry bureaucratic jargon, but it's actually fascinating physics.
Exactly, because since we don't do love underground nuclear testing anymore, how do we know the aging weapons in the stockpile still work, or even more importantly, are still safe?
Right. And the answer is supercomputers.
Yes.
Los Alamos uses some of the most powerful computers on Earth to run incredibly complex simulations of subatomic physics, modeling exactly how the materials inside a warhead age over decades.
Which ties perfectly into their exhibit on the history of supercomputers, a field Los Alamos has been pioneering for decades.
Oh.
They also have an exhibit on the Los Alamos Neutron Science Center, or LANC.
LANC is another great example of swords to plowshares. It's a massive particle accelerator.
Okay, break that down for us.
Sure. They accelerate protons to incredibly high speeds, smash them into a target to create a beam of neutrons, and then shoot those neutrons at various materials to study their atomic structure. It's used for everything from material science to creating medical isotopes.
And the breadth of the research on display just keeps going. It goes way beyond defense. You can explore Los Alamos' contributions to space exploration.
Oh yeah, their space stuff is incredible.
They specifically highlight their work on the Mars Science Laboratory, which you probably know as the Curiosity rover. Los Alamos developed the ChemChem instrument for it, which literally fires lasers at Martian rocks to analyze their chemical composition.
Lasers on Mars. It
Yeah.
really doesn't get much more sci-fi than that.
It doesn't. And then you turn a corner and there are exhibits on nanotechnology. There's research showcasing algae biofuels. So you have high explosives on one side and cutting-edge green energy solutions on the other, all under one roof.
If we connect this to the bigger picture, the sheer breadth of what you just described creates this incredible, dizzying juxtaposition.
Oh, totally.
Think about the physical space of that museum.
Yeah.
You can stand in one room and look at physical models of world-ending weaponry, the absolute extreme of destructive power. And then, in that very same building, just a few feet away, you're looking at algae biofuels that could power a sustainable green future, or the laser technology driving the Curiosity rover across a whole different planet. It brilliantly captures the dual nature of scientific discovery. The same foundational physics has the capacity for both unimaginable destruction and boundless innovation.
So what does this all mean? We started this deep dive standing in front of an old ice house in 1954, staring at a heavy steel vault door where only a handful of cleared officials could look at the remnants of nuclear testing.
Right.
And we followed that thread through 1963 when the doors finally cracked open to an eager public, through the video discs and satellite models of the 80s, all the way to a custom-designed, completely free museum in the center of downtown. It's an incredible journey from a locked vault to a world-class institution that lays bare both the heaviest moments of human history and the brightest possibilities of our future.
This raises an important question, and it's something for you to mull over long after this deep dive is done.
Let's hear it.
We've traced how knowledge was initially locked away behind vault doors for the sake of strict security, and we saw how desperate the public was to understand it once those doors finally opened. When we lock away our most significant scientific breakthroughs, what happens to public understanding?
That's a great point.
As modern science advances into incredibly complex and potentially dangerous new frontiers today, whether we're talking about artificial intelligence, bioengineering, or new forms of energy, we always need that initial icehouse phase of extreme secrecy. Or, having learned from the history of Los Alamos, can we figure out how to build a public museum right alongside the discovery, keeping the public informed every step of the way?
That is a phenomenal thought to leave on. Thank you so much for joining us on this deep dive into the vault and the history of the Bradbury Science Museum. We hope you enjoyed the journey, and as always, we encourage you to keep exploring.